Okay, now we're going to talk about measuring objects on a ruler. As you can see, and this is a centimeter ruler. It's not labeled as centimeters, but that's what it is. This pencil is longer than 6 centimeters. So we're not able to say it's 7 centimeters. It's definitely 6 point something. And that's where the estimated digit comes in. So I, for example, might call this 6.1 centimeters. And as you can see, the 1 is the final digit, and that is considered to be the estimated digit. Now suppose that we're measuring an object where it falls on the line. We still are unable to call this 6. We have to say more than that, 6 point something. In this case, because it's exactly on the line, then you would record this as 6.0. And the 0 is at the end of the number, and it is the estimated digit. Because it is on the line, you add a 0 at the end. Here we have a ruler that doesn't seem to have very many lines on it at all. But it illustrates a point that I would like to make about how you add an estimated digit. In this case, to record the length of the pencil based on the lines of the ruler, we know it's going to be somewhere between 0 and 10. And that's all we know. Maybe it's 6 centimeters, maybe it's 7 centimeters. Could we say 6.5 centimeters? And the answer is no. Every line on this particular ruler is worth 10 centimeters. So you would estimate to the ones place. You estimate 1 power of 10 smaller than what the lines are worth. So in this case, we could say 6, we could say 7, but that's all we could do. Now suppose we have a ruler in which every line that's printed on the ruler is worth 1 centimeter. We can estimate to the 10th place. So perhaps you might call this 6.7, or perhaps you might call this 6.8. Could we say that this ruler gives us a measurement of 6.75? And again, the answer is no, because every line is worth 1 centimeter, so we can only put the estimated digit 1 power of 10 smaller than what these lines are worth. So 6.7, 6.8, but we could not go out to the 100th place. We just don't have that level of precision with this ruler. And now finally, let's go to an even more precise ruler and measure the same object. So, as you can tell, this ruler has every line is worth 0.1 centimeters. I'm going to give you a close-up of expanding what that looks like. So, we are now at a point where we can measure somewhere between 6.7 and 6.8. So let's say we think it's roughly about halfway between 6.7 and 6.8. You might say that the measurement is 6.75 or perhaps 6.76, but the final digit, whatever that number is the estimated digit. And because every line was worth 0.1 centimeters, the estimated digit was 1 power of 10 smaller than that particular measurement. So we go out to the 100th place. Okay, now let's consider some examples where the length of the object, in some cases, is exactly on the line. Remember, we mentioned that we're going to have to add a 0. If the first measurement is just 6, and we cannot say anything more than that because we are only going to the ones place. But now, with this measurement, we are able to go to the 10th place. And let's take a moment to think about what that means. I'm saying that 6.0 is a more precise measurement than just 6. It's a different ruler, and therefore it does require a different level of precision. So, can you guess from this third ruler, if we're going now out to the 100th place with our final digit, this particular pencil on this ruler would be measured as, hopefully you said, 6.00 centimeters. Okay, so that is the most precise of the 3 measurements. I'm not changing the value. It's still considered 6 on a calculator, but in a science class, 6.00 is a different number than 6.0 or just 6. And that leads us to our next discussion, which is we'll be talking about significant figures. Okay, so we're going to talk about significant figures now, or sig figs. In a measurement, The number of sig figs include all of the known digits plus one estimated digit. So in this example, the measurement is 6.7. The known digit is a 6. Because we estimated that final digit as a 7, that counts as well. It's all significant, so this number would have two significant figures, or 2 sig figs for short. In this example, you can see that we now have a more precise ruler. Take a look at where the final estimated digit should be. Are we going to estimate to the 10th place, or are we going to estimate to the 100th place? Hopefully, you can see that because every line that's printed on this ruler is worth 1/10 of a centimeter, then we will estimate to the 100th place. So therefore, because it's exactly on the line, it would not just be 6.7, we get to add a 0. So 6.70 centimeters. Pay special attention to the fact that I had just shown you 6.7 on the previous slide, and now I am showing you 6.70. So in this chemistry class, 6.70 is more precise. How many significant figures is a measurement of 6.70? 3. So this measurement has 3 significant figures. Not 2, it has 3 because we do count that final estimated digit.